Today, I'm pleased to introduce today's session, Unstructured Data Processing from Cloud to Edge. And our guest speaker here is Tim Span. Tim Span is the principal developer advocate at Zillow with over 12 years of programming and data engineering experience. And before joining Zillow, Tim was a principal developer advocate at Cloudera, promoting open source data engineering and streaming technologies. And then previously, he was also a developer advocate at Stream Native, a principal field engineer at Cloudera, a senior solution architect at Eris Data, and a senior field engineer at Pivotal. He blogs for DZone, where he's a big data zone leader, and he runs popular meetups in Princeton and New York City on topics like machine learning, big data, deep learning, etc. He's also a frequent speaker at conferences like Pulsar Summit, Data Summit, Con42, etc. And Tim holds a MS and BS degrees in computer science from Montclair State University. Welcome, Tim, and get started on your topic today.
Very awesome. Thanks for the introduction. Let me share my screen here. Hopefully all that is working fine. It's always a mystery, especially when you've got a couple of different screens here. And I've got broadcasting from my arcade center here, so it's a little different from my normal broadcasting booth, but this one has more arcade games in it, which is kind of cool. Hopefully they don't automatically start up. I have had Pac-Man start up in the background behind me, so we'll find out. Hopefully not. I don't think I have to do the intro there. So this one is pretty straightforward. This one has been rapidly evolving as what you can do at the edge has been rapidly evolving. If you've watched the AI news, which changes every 3 to 4 seconds, maybe quicker than that, there's been some new models coming out. And I downloaded one with Olama yesterday on a new device that I got 2 days ago. My friends at NVIDIA have got me a device here, and we'll show you some demos on it because stuff just works, and it works really fast. I was pleasantly surprised how quickly you can just get these things done. But yeah, we'll do introduction. We'll show some edge cases. We'll show some demos, do a bunch of stuff. Now, previously in former lives, trying to save things, especially things that were unusual data. I mean, they're not unusual now. I mean, think of a use case for Gen AI and the new AI use cases that's not using big text, interactive text, images, video, sound, all kinds of Slack channel, all kinds of weird stuff from everywhere. It was crazy. Where do you store it? How do you retrieve it? What do you do with it? Well, you can do a lot with it. While traveling in the field with my Milvus bird, we found you can run, you know, these vector databases anywhere. And there's data everywhere, even unusual places, sometimes not connected to even the internet. And you got to do what you got to do there. So we get all this crazy different types of data, sometimes interconnected, what I've seen coming from traditional data engineering, more structured data stores, even in Hadoop and S3 buckets and object storage. Being able to connect this richer unstructured data with structured data isn't hard with something like Milvus because you have the ability to add metadata, JSON fields, different attributes. So I could put I could link whatever data I have, say it's a picture, put all the metadata relevant to it. Also put, hey, if it's connected to an Oracle record, or if it's connected to a MongoDB record, or whatever, any other database, which you could have, a bunch of databases for, relational data and more structured data. But with Milvus, being able to store these quickly and being able to get them back just as fast is pretty amazing. I'll show you on the edge, it's a little different. And the flexibility and the different deployment models make for a lot of interesting use cases, especially different size boxes. You could get a $10 device, or you could have a several $1,000 device that's got 64 gig of RAM and terabytes of storage. The edge isn't just a tiny little button sensor. It could be an edge server. It could be, one of these powerful NVIDIA boxes. There's a lot there. So we get all these things. We use a deep learning model to get these encoded right with the proper embeddings, get them into our vector database, get them indexed, and then, have them stored where they need to be stored and ready for retrieval instantly, even if that is running right on the edge here, right on your device. Again, there's a lot of data out there. It's just going to get bigger, and there'll be more sources of this. I mean, real-time video feeds are coming from eyeglasses, smart cars, smart devices, smart shirts. I had a use case. I was working with someone within a dangerous space. They had a smart shirt that had a live camera. It was checking for thermal. It had sensors for oxygen levels. So in case the person was in a dangerous location, you'd get that instant feedback to know, hey, dangerous stuff's going on. So there's a lot of different ways to do things, but why use a vector database, especially in the use cases where a lot of the stuff is on the edge, or it's communicating from the edge to maybe a cloud or a central cluster. Obviously, being able to do high performance search is really important for a lot of use cases. But when you have a vector database, you can also do things that you expect to be able to do in a database, create tables, collections, uh, insert records, read them back, do updates, delete data, make sure everything's fresh, make sure you get your results, immediately. Make sure things are stored, even if you have to shut down, if things restart, if you lose a node, things that happen in the real world. You want to make sure this data is always available, regardless of what happens, even if a node goes down, being able to handle those things, being able to scale up and add additional storage, add additional query, being able to support more users, more data, more collections, more applications without having to worry, am I going to hit a wall sometime, or I'm going to hit a cost wall? The great thing with Milvus is open source scales out as big as you need. It's not, a limited featured version. There are people using open source Milvus around the world in very large form. And obviously being able to manage your data, which means you got to be able to ingest it, index it, query it. And if you're not doing backups, I mean, yeah, this is unstructured data. Maybe you don't think of it as the same way you did with your relational data, but backing up, migrating between versions, migrating between different environments. Like I'll show you backing up from one of my devices, and then I can load that into the cloud, and that can be automated or built into an application. But those things are important, and that's why you have a database and not just, some library somewhere that maybe stores something, maybe saves it, and you need to be able to operate it. If you're doing a toy use case, I've got 5 documents. I want to do a chat on them, and maybe it's just something you're learning. Maybe it's not that important. But once you get to the point where this is something people rely on, and believe me, when people see the power of being able to do searches, take an image and use that to search with, being able to do lookups against text, real fast search things. People will love these apps, and they quickly expand. They quickly need operational concerns. People are where we're going to deploy this, and being able to having those options, whether it's in different public or private clouds, or in your on-premise infrastructure or Docker, or use Zilla's cloud if you want fully managed environments. Obviously, with any database, anywhere you have data, you better be able to monitor it for health and performance concerns, so things are running well, especially you get enough users. In the beginning, everything is sub-second, then all of a sudden you add 10,000 more documents and 100 more users and things slow down, you need to be able to monitor what's going on and know when you need to expand or maybe add indexes, change indexes. And the Milvus community is always out there to help you if you're, started somewhere and you're a little stuck or you're having problems with performance. Definitely reach out. We'll give you all those different channels to reach us. Obviously, when you have devices deployed, I mean, you're not going to just have one device sitting in one location. All of a sudden, it's in all of your trucks, it's in all of your offices, it's in all of your ATMs. These things quickly expand, as I've seen in IoT use cases from manufacturing to oil drilling. You could be in thousands of locations, maybe running on different desktops for different purposes, like security or monitoring. Being able to support a lot of different users and apps concurrently with security. If that hasn't come up yet, I don't know you have a production app yet, but that's important. And the features that Milvus makes that really possible is having a very elastic architecture. We won't go fully into that. There's a lot of articles on that. When I saw that, I was impressed. It reminded me of the optimal Kafka and Spark architectures where things are distributed and things can scale up independently. You have a separation of compute and storage. It's the design principles you expect in an enterprise level system. Being able to support a lot of different indexes and more always on the way because data changes. And as you see these models improve, new ideas come out. There's always new indexes, and Milvus just finds a way to quickly incorporate them and make use for them and make them available so you could try different things. This can be important too on edge devices where you might want one that's maybe a little faster. You got that as an option there. Lots of different ways to do a search, and one that's coming from traditional data stores, the ability to tune how you do consistency. That's pretty cool. I mean, it's usually you're stuck in cap and whatever decisions were made a long time ago, those are the ones you're dealing with. You've got options here. You may not need that for most use cases, but it's nice to know you have it, especially if you're doing some weird edge cases and such. Again, support for a lot of different hardware, accelerated compute, and there's a bunch of them out there, and they're all in the database, which is cool. We mentioned lots of different deployments, all the indexes you expect to have, binary, sparse, ones for GPUs, specifically for NVIDIA, and I'm using some of those on one of the edge devices, so that seems pretty good. Lots of different ways to search. I mean, it'd be nice if there was only one way to search, but there is a bunch of them depending on if you have sparse, you have dense ones, different range, searching multiple vectors, grouping things together, filtering your data with all those metadata fields we mentioned so you can really tune what results you get back. Lots of options here. This makes for a really nice solution for the edge, but also for wherever you're running. Milvus is really a general use vector database. Even if you don't have Gen AI or AI use cases, it solves a lot of problems. I've been really happy with it. This is some of the devices on my desk there. There's a lot of them, but Edge AI is just going to keep expanding because as we push automated systems, robots, people enable smarter cities so things will just work. You need sensors and cameras and audio, and to be able to have local and remote in some kind of federation where you could find results you need right away. See if something's wrong, like hey, there's a leak in a pipe somewhere. Be able to do that and detect those things quickly. There's a gas leak, there's a fire somewhere. Things you want to know right away. Being able to have AI and vector database and the ability to process, data that you need for the real world. I mean, unstructured data is real world data. I have a picture of what's in front of me. I've got the audio of a fire. I've got a video showing something going on, operational things you got to worry about, safety. Those things are very important for, as we improve cities. The same thing for manufacturing. Has there been a defect, being able to figure that out right away, and being able to store locally all the, say, for one particular machine, what are the defects that it's had in the last 1,000 hours, 1,000 years, whatever it is, as much data as you want to store. You could store a lot of it in these new edge devices, now like that, terabytes. But even if you just store the last 1,000 errors of good data, so when an image comes through, I could check it and yep, that's still good. A defect, look against known defects. Hey, this is related to an error we had 2 weeks ago, and we can connect, look up the connected data, and I could push it to a local operator, push it to a Slack channel, messages, and then I can find out what exactly is going wrong immediately. Maybe even solve it automatically with AI if you've got the right model and algorithms. But the first step is detection, being able to search quickly and do that locally. So maybe I'm in a secure facility that doesn't allow me to leave it. So I can have a small edge server, or I can have a powerful edge device like NVIDIA Orin or something sitting right there that can find it, detect it, check it against models for errors, and also check the vector data store locally to see, is this related to something that's a problem? Maybe it's not. Maybe it's something we've seen before and people have got involved and say, no, don't worry about that. When you have autonomous cars, which, we're getting close, there's a lot to go on there, but having a vector database in there that knows what people look like, there's a lot of great sensors and LiDAR and cameras and detection algorithms. But, having a fast data store that I could get to and not worry about, even if there's no network connectivity, to know, hey, this came up, do something. And being able to get those results right away. Retail, obviously, having to check out your own stuff isn't everyone's favorite, but having it smarter and be able to search things is pretty cool. And again, doing the same thing in your house, being able to know everything in your house. Is that, oh, that's Tim's cat again. Okay, that's Tim's cat again. Just take a picture. You don't have to change things. It's the cat. Don't worry about it. Oh, I saw a quick question. Maybe I'll take a quick look there. Are search types directly linked to the corresponding indexes? Yeah, we'll get into that, but yes and no. Most of the searches support most of them, but obviously performance, having the right index makes everything better. It really depends on your data, but most of the search types are supported by most of the indexes. I'm trying to think if there's any that aren't. I don't think so, but we could take a look at that. We'll get you a deeper answer on that later. So cool thing. Again, I've got a couple devices running right next to me. I've got a Raspberry Pi 5 with the new AI kit added onto it, so it does faster AI inference. And I've got a NVIDIA Orin running right at the edge of my hand here. They let you do a lot locally. Again, being able to have the local search right there. If you've got things that are proprietary documents, things that are secure, things that you not risk having on an open network, maybe it's privacy issues. You want to keep things private, but you still want to be able to run applications, run AI, get things done. Well, you can run that right on that device. No one else has to see it. Everything can be encrypted, SSL all around it. Maybe even no network on that. It might not need it. It might just communicate to a local screen or to a local device, or maybe just pushes out. I send my data to a secure Kafka stream, or in my examples, you see I'm pushing things to my own Slack group. Being able to do on-device object detection, lots of different AI things, especially if you've got one of the NVIDIA ones, which supports a lot of small, medium, and large language models and all kinds of models on there for pretty much everything. You go through that list with the NVIDIA NIMs, and it's amazing. Now, being able to run Milvus Lite on most of these devices, In the latest version, it's just a pip install. I can run the full local database there. I don't need to run Docker. I don't need to run something a little bigger, which may take some of your, really important resources. Now, Milvus Lite is light. I don't want to put, as you can see, keep the number of vectors in there. Not super huge, but we can back them up and send them somewhere else as needed. And you could also have those refresh, keep them just the most recent ones, and then send older stuff up to the cloud or distribute it in other avenues. Pretty easy. Now, what's making Edge better? I mean, I call these the hyper enablers, and it's just things that are making this a no-brainer that you're going to have them. 5G, and there's networks everywhere and they're getting faster. I could tell you driving across the country, maybe not as much in Wyoming and South Dakota, but it's more than it was 2 years ago. I could tell you that. And those are just going to be around every city. You are going to have a lot of bandwidth, and it makes sense to have devices that can take advantage of that and produce data and capture data right there. IoT and the number of sensors have gone down in price, the number of types of sensor. LiDAR used to be something for the rich and famous. LiDAR is now $100, and there's more and more sensors. I mean, I've got 100 sensors on my desk. There's so many cool things you can capture them. You see when things are going on, like when there was air pollution, to be able to have local pollutions that sensors that could check for different pollution levels, different ozone levels, important things. Being able to tell when things are going on, detect fire, smoke, all those things are important for so many use cases, and those are just getting cheaper and easier. Computing power just keeps going up. Raspberry Pi used to be pretty cute, and you had half a gig of RAM, and you had a okay CPU. Now you can get 8 gig of RAM in a Raspberry Pi. There's other Raspberry Pi equivalents with 16 and 32. I've got 64 on an NVIDIA. I've heard of 128 and even more. So you're getting more RAM, more CPU power, full GPUs, TPUs, custom ASICs in there to give you a lot of compute power and more storage getting there. I mean, it used to be maybe I had a couple of gigs on there. I can have terabyte drives. The new Raspberry Pi supports real SSDs. I mean, you could put serious amount of storage affordably with low power usage almost anywhere. And that's just going to get more and more faster, better every year. Being able to have really powerful neural networks and generative AI, large language models right there running and running fast, a decent number of frames right there is opening a lot of interesting use cases, some we haven't even thought of. Being able to do unstructured data processing, capturing all of that, and having a database that enables you to index that and search that at scale very quickly, even if it's on a phone. I mean, it's incredible what's going on, and it's just going to get more. Obviously, really important unstructured data is in the real world, and what's in the real world? These devices. So vision, getting images and videos, getting audio from all the cameras and microphones, getting raw text. It could be spoken. It could be captured from different input devices, local things going on, or even produced by the local model. Again, having those neural networks, all of that right there at the edge, pretty powerful, pretty important. I'll show you the demos after I finish the slides. So in case something goes wrong, I'll have a little time to restart stuff. I'll be working on an edge device. Yes, I am. Okay. Maybe I should show it now. Okay, let's show you real world. And hopefully people don't mind command line. I'm going to show you a little command line just so you know it's a real edge device. Otherwise, they're like, is that a real edge device? Maybe it is. This is my local device here. Just show you the horsepower here. 64 gig of RAM, a lot of CPUs. This is the NVIDIA, and on here I am running a Milvus server in Docker Compose, as well as if you see this little .db, this means I'm running Milvus Lite. So I've got 3 ways of running on this particular device that I got in the mail yesterday, which thank you to NVIDIA for having this supercharged and ready to go, because it took 10 minutes to get up and running, and that was just installing a couple libraries, and I put some extra ones on there. So I can run a local, I have a camera pointing to some stuff on my messy desk, and I could run that and run it to the cloud, which is Zilla's cloud. And while that's running, we'll go up to Zilla's cloud, and you can see I've got a couple different collections here in my serverless environment. One of them is Orin Edge. This is the one that is getting called from here. This is an Orin. So what this app is doing, and I've got the full source code out there. I've got a camera right here and it's looking at the junk on my desk, and then it goes into an algorithm to give you description and a nice caption there. And then as a way to segment it, obviously I'm sending this to my vector database, and you can see I've got a couple of them here that we put in recently. I've got a couple little metadata. I put that caption in there. I put the file name of where that image is. I could put that in S3. I could put that in Minio. Right now I have that locally, trying to figure out where I want to put these images. That is always a thing. Or do I keep them for long? You know, that is a decision based on your storage and your apps and what you want to do with it. Obviously, I have the vectorization of that image, but yeah, you know, with the metadata, but it's good to have that. So that version got sent to the cloud. So it's running on the edge here. We had a network, I send it to the cloud. Now I also have on this machine running is Milvus and Docker Compose. You can see it's the GPU version because I have a pretty good GPU here. Like it's better than my laptop. I think I'd rather use an Orin than a PowerBook. So I don't know if I want to run my slides off there, but I could. Okay, so we can run and send it to that local Docker version. Now that Docker Compose version of Milvus that's running on this NVIDIA hardware here is connected to my I put connected an Attu instance. If you haven't used Attu, it is a really awesome UI. It's probably the best free UI I've seen in a in the open source. I mean, it is pretty nice. I like this UI. So we'll show you how this works. So we've got all the collections on here. I'm logged in. I'm using 246. I've got a GPU edition here. I only started this today. I thought I should probably have this on there, so I added this. So if we look, I've got a collection here that's loaded. Only 5 rows in here. You can see I've got indexed vector, got time, caption, couple fields. Now I could do a search here. I could also filter on the different fields we have. So say you wanted to filter on, if we had a lot of data on the caption, maybe one that just says laptop. I don't know. We could do that caption. Is it lowercase laptop? Yeah. We could search there. Only 2 of them had that. Again, that's running on the device along with this UI. So you could see the data there. Every time I run one of these, as you see here, we get the result in the command line, which if you're doing this headless, you're not even seeing that. So I make sure I send those results to my Slack channel. You could send it anywhere. You could send it to a data store. As you can see, I've got a lot of weird junk on my disk. I've got 2 of the Milvus birds. I got a cat, got a button, got a little Pac-Man game. I got the big one behind me, but it's too messy to show you all that stuff. It'll break the internet. We don't want to do that. So as we run it, we got it uploaded there. and we've got it available so you could see it in the display for my local Milvus running in there. So we've got the third way, if you look at my different runs, is just a regular run. This is running to that local Orin Edge AI. That's my local Milvus Lite database that just needs Python, which is great. So you could just run it. You don't need anything special, but that's only stored in that local little database. And there's some things we could do with that local little database. Like you can search it. So I could run my search against that. Oh, is that going to pop up a screen? Yeah. I don't think I want to pop that up. That pops up on another screen, which you won't see. So we won't do that one, but we could do a search and it gives you the results and then it posts them to Slack channel. Good way to do things remotely. So that is a couple of devices running. I'll show you the Raspberry Pi one as well, and then give you links to the source codes if you want to play around with it on your own. Now, on uh, my device, I can connect a notebook up to Zilla's cloud so that I can search those ones. So that's a great way if you have data that's remote and you want to be able to access it. Pushing it to the cloud makes a lot of sense. Very easy to access through either the UI or through a notebook or through anything else. I'll show you in the slides how easy it is to pick between, I'm going to do Milvus Lite, I'm going to do Docker, I'm going to do a regular little standalone instance, a little cluster, cloud. You're just changing your login. Nothing has to change much. It's pretty cool way to do that. But let's show you the Raspberry Pi. The Raspberry Pi I have running over here. And this one is also have a llama running on there, but I don't have the screen hooked up, so I don't want to show you that. So what we're doing over here is we're doing pose estimation using the Halo Raspberry Pi AI kit, which enhances the abilities to run some different ML, deep learning, and AI use cases on these affordable Raspberry Pis. It is a nice enhancement that is hooked up to a camera next to me, and that will run pose in quiet mode. It's still a little noisy because I got some errors in there because I turned off the screen and it doesn't really want you to turn off the screen. It found my eyes. Don't know if it found the bird's eyes, to find the cat's eyes. Yeah, so this is running against what's over there. Yeah, this is also doing a similar thing, but this one is just connecting to the cloud because I really don't have the storage on there to do much. I can run it in Milvus Lite as well, but just to show you some options. So that is the Raspberry Pi pose, and I'm just grabbing left and right eye coordinates in the confidence that it found eyes and just storing it there along with the vector. And again, ooh, that's creepy. That is a blurry picture of the Milvus, but it found its eyes. It's pretty special. But yeah, if I hold it close to my face, you get the right results. But just to give you an idea there, yeah, so we can run on a Raspberry Pi, and you don't need that extra AI kit. It makes it nice so that you can do more edge stuff there with a little power. They're still working on some of the libraries. It does the basic stuff like pose estimations, segmentation, object detection. For an inexpensive device, it's not bad. I've been pretty happy with it, and all in Python, so it makes it easy to write applications with Milvus and whatever other things you want to do there. Again, I also have an older Jetson Xavier NX that also runs Milvus, and I've got some articles on that one. The Orin article hasn't come out yet because I got Orin yesterday, And we have this webinar, so there's some other stuff going on. I also have some working with some smart cameras. I'm working on that if people are interested in those use cases. If not, let me know. Oh, is that the Milvus UI? Those are all. Let me go back in there. This right here is an open source Milvus UI. This is called ATTU Atu, I call it. I don't know if that's what it's really called, but that's what I thought it's called. This is the local one running on the NVIDIA Orin. That is not the Orin device. They have a lot of UIs and some pretty impressive stuff. I'm not running those yet. That'll be coming probably next week. I didn't have time to put that in here. I'm still trying to map out a nice application there. Yeah, so this is an open source one that works with Milvus. You don't have to use this, but it's nice. If you're using Zillas in the cloud, which there's a lot of free space and free availability there, this is the UI for that one. That one's pretty nice. This is Jupyter Notebook, the same Jupyter Notebook. This one's running on my Mac. It also can run it off of the Raspberry Pi or off of the NVIDIA box. Run server, run local. Yes, that is my really sad way of running different applications, because there's 3 different apps here. See, there's Orin Cloud. If I look at Orin Cloud, and I'll post this source code, you can see here, this is connecting to my specific serverless URL at Zillas, plus taking in a token. So Run Cloud just runs that and passes in the token. Orin by itself, this one is connected to the database. And if we look at the database, this is our local Milvus Lite. So Run runs that one. And then Run Server runs the Orin server, which is also running. That's my local IP. I could go by name, could go by something else, but this is the Milvus that's running in the Docker Compose here. And as you can see, it's got etcd, it's got Minia. I guess I can store the images there. And there's Atu, which is the UI. Again, you don't need to use the UI, but I think it's pretty awesome looking, and it lets you look at all the schemas, do a vector search, browse your data, also do stuff like backup, export your data, give you example source code for doing a search. I mean, it's a pretty cool tool. So those are what the tools are. Let me get back in here. Hopefully that answered your question. So we're running with a lot of different hardware examples, and there's more. People are coming out with different hardware, lots of stuff there. Again, we mentioned some of the reasons why you want to use a vector database on the edge. As you can see, flexibility of where you send this data. I mean, running it, Milvus Lite is the easiest, takes up the less resources, but the data is just there. So if you want it somewhere else, obviously you could send it somewhere else. You could do send it to multiple locations. What we used to do in Hadoop with dual ingest, you could do that. You could also do backup. I'll show you how to do that. Having instant local search for whatever's on that box. I mean, if I'm running a NVIDIA box, I'm going to be capturing a lot of images, text, logs, maybe sensor results. I've got some sensors for the NVIDIA. Whatever's on there, being able to instantly get that data back and not have to go over a network. Again, not needing a network, being able to do your own local RAG solutions, and making your edge AI even more powerful. And we can run Olama there. Ton of different things that could run on the NVIDIA. Being able to do local live video processing and not have that have to go to the cloud. Oh, RPI. Yeah, that's, sorry for my stupid abbreviation. That's just Raspberry Pi. I probably shouldn't abbreviate that. I don't know if that's their official one. I think it might just be Pi. But yeah, RPi, Raspberry Pi. Sorry about that. Once you have so much stuff, you got to do acronyms and abbreviations so no one knows what you're talking about. I mean, it makes it fun for everybody. Sorry about that. So if I want to run Milvus Lite locally, which runs great on your laptop or on any of these Unix, it's pip install. Obviously, you want a newer version of Python 3 on there. And that's all you got to do. Install. Now it's running and available locally. I can run it in Docker. Obviously, I got to use either the Docker file or a Docker Compose, or I could also run it in Minikube or something else. I can also run an Edge server. There are Edge devices which are even have more storage and more CPU and more RAM, and you can run the standalone version there or the Docker Compose version, or even a tiny cluster with a couple of them. What's nice is it doesn't matter. You saw we just have to change a couple variables and now you talk to that one. Pretty easy. It's the cloud. I add a token. This is the difference on the your Python source code. You know, do I point to a local database file? Do I point to a local server? Do I point to a server and pass in a token? It depends what you're doing. Pretty straightforward. Now, what's nice too is when you're dealing with the edge, obviously Python is first class citizen. A lot of people write their apps there, but other apps and languages are supported and are pretty common on some of these devices like Node.js. Java surprisingly is on a lot of them and it works pretty well. If you're coming from the Java space, let me know. I've got like 20 years of Java and there's use cases for Milvus and Java together. Golang, obviously native cloud language. Go works really well in all these environments. You want to just do it with curl? There's RESTful APIs. You don't have to write serious code. We're going to have a webinar on .NET C# version, which is looking pretty interesting. We also have Spark and Kafka and Ruby and a lot of user-developed interfaces and languages out there. So if you're interested, there's a lot of options. It doesn't just have to be Python, though obviously Python is pretty easy to do. As we mentioned, lots of different use cases. Anomaly detection at the edge is pretty cool. Being able to search audio. So if you use that for security, have your own device answer what you want and just have it locally. It doesn't have to go to the cloud to share that you asked for where the Pepsi is or where's my Milvus doll. You don't have to do that. Facial recognition, again, dealing with autonomous things and robots. Again, being able to be low latency, offline, secure, localized storage, pretty awesome. And then once I get it to the cloud, the world is your oyster, wherever cloud you want to run on, whatever kind of fancy hardware you may have. We've got a ton of different embedding models from some open source, some paid like OpenAI, but whichever one makes sense for your use case and your data. You don't have to use a paid one. There's a bunch of good ones in the open source that work really well. And there's a ton of awesome LLMs out there. And we work with all those frameworks. You don't have to worry about, well, if I'm using LangChain, can I still use Milvus? Yes, you can. Will you run that at the edge? Well, you could, especially on an NVIDIA. So I got data. I'm doing it all locally. And then once a week, once an hour, once a minute, I don't know, once a day or once, or maybe when you have it for an event, say I put it at the Olympics. When it's done, I want to put that in a cloud and put all my data from my 10,000 remote devices together. Well, I can very easily dump that data from Milvus Lite and import it right into the cloud. We mentioned that dual ingest, the old Hadoop Spark way. I could just make things push directly to the cloud. Again, you do have to have a network. They are pretty prevalent, but when you're doing distributed programming with edge devices, you got to think about that. We could all use the tried and true methods for messaging. I can message the data through Kafka or Pulsar or something IoT specific like MQTT or some other protocol if I want to send this out somewhere. We support importing Parquet files if you're from the big data space. So you could send this to a regular Kafka Pulsar app, have it dump it to a big Parquet file, use something like NiFi, and then we could just import that into the cloud. We could push this unstructured data to an object storage, and then again send the other part of the message through something like Kafka or Pulsar, or just send the whole thing right to Milvus. Depends on what security performance. Oh, smart. Yeah, it's a blip. I'll show you the source code there. Somebody knows this stuff. Yep. Mishort. That I don't know. Um, we'll have to take a look at that one. So Milvus Lite Export command line tool comes with the install. You just point to your database, point to where you want to put it, and pick your collection. You could have multiple collections. So I would probably do one database per collection, because there is, a lock on this, as it is a regular little file. It's not the real Milvus. They could do all the fun concurrency, something to think about. One database, one collection, one app. If you're doing these, especially on these small devices, I mean, how many are you going to do there? But yeah, just export that and you could install it somewhere else. I've got the source code for all of these. I will show you that along with articles describing how we did it, what algorithms, examples, all the libraries you need, the full packing list there, how to get started, example runs. So it's not too hard there. This one is from the older NVIDIA device. Again, I got this. I didn't write that article yet. I'm feeling bad, but I wish we had some extra days in this week. Maybe somehow I'll push it through. I want to do some more advanced use cases for that. For that, let's get to that source code. This was the one for the that we did on the Raspberry Pi. We did two different ones on the Raspberry Pi. This one I did just recently, and this will come out in an article very shortly. This is for the pose estimation. We have another one here. This was the original AI kit one I did, and this is for just detection. We've got all the source code for that one, and that is a giant corn. I won't tell you where I saw that giant corn. Xavier Edge. This is, I think, the one you were asking about. And we've got the source code here. As you can see, it's the blip processor. That you got that one right. And we have blip down here. So I capture image off my camera, run it through blip. I'm using Hugging Face there for that. And I think it's the Salesforce blip version. And that runs pretty good. Grab the caption, put that into Milvus, and post that into Slack. The Slack library for Python, really nice if you haven't seen it before. Oh, dual ingest is a technique that was, it's not optimal, but it's a way if you need to populate two databases or two things at the same or similar time, is exactly what it says, dual. I send data here, send it here. That could be multi-threaded, it could be multi-process, or it could be serially. But what it is I want to have a copy locally and I want to copy somewhere else. Now, easiest way to do that is just to do that. Connect to this database, insert it here. Connect to this database, insert it there. Inserts are really fast. So unless you're doing 30, 60, 120 frames a second, and you're pushing a lot of data through, that is an easy way to populate them both. Obviously, you could also have an app that checks and sends it later. You could also write the logical JSON that would go to be an insert and store that and have a app do it. There's a lot of distributed programming techniques to handle sending things to multiple places. Milvus doesn't have auto federation yet. I don't know if that's something that they think about in the unstructured data world. Coming from the structured data world, people like to do that. That might be a thing, or maybe you just send it to the cloud. Again, that's not an advanced technique. That's The simplest way to do something, to send it both places. You know, if I have to send it's send a carbon copy somewhere. Uh, if you liked what we're doing, please give Milvus a star. You know, the more people in the community taking a look, trying things out. You could be a commenter by just doing documentation, and documentation is really important. Doing examples, looking for simple bugs, typos. So definitely check out our source code. We are on Discord. There is a lot of cool content in there. There's also an AI bot to auto answer questions, and most of the engineers are on there. Maybe not every day. There's always at least one engineer on. So if you've got a question or just comments, Discord is a great way to do that. A lot of stuff going on there. We
Hey,
added a
Tim,
cool, yeah,
sorry to
we're running
interrupt.
out of time.
You have a question that someone wants to answer, like unmuted, so I'm going to
Oh,
allow
okay,
him to ask his question.
sure.
Shri Shrikant, I'm gonna unmute you if you'd like to ask your question now. He raised his hand, so.
Yeah, yeah.
Or you can type it if that's easier for you.
Yeah,
I know you
whichever,
raised your
either
hand some
one.
time ago.
Oh, I hope you didn't lose their question. Unless it was really hard, then I will just say the
Or
answer is 42.
if it was already answered,
Oh,
maybe.
that could be. That could be. You say enough stuff and randomly it's the right answer.
Okay.
There's
Well, if it comes up, please put it into the chat, and we'll get that answered.
yeah, and if you don't get it now, put it in Discord, send it to me in Twitter and LinkedIn. Come to the meetup if you're in New York or California or Berlin. Uh, or just email me. I'm always looking for cool stuff, or put it in Stack Overflow, where we try to monitor all the Milvus channels looking for questions and comments. We've got cool things you could try online. If you want to try your own demos there without installing anything, we've got the cool OSS chat, which is an example of using Milvus to chat with different open source documentation. And it is a pretty cool way to do that. Nice little example. If you want to try things out, we could try Zilla's Cloud for free if you don't want to install anything. You don't even want to install the Python library, up to you. All the information is there. If you want to see more of the demo, we got a couple of minutes. Otherwise, if you got more questions, I'm not seeing any yet, but if you didn't fall off and if you're still on, you want to ask that question in Q&A or chat, let you know.
Yep.
Let's
You
see.
have about 4 more minutes if you'd like to share something,
Okay.
Tim.
Yeah, okay. Let's yeah, we got the Discord now. All the slides will be shared. All the links to the source code are shared. Pretty straightforward. What's nice is with Milvus is regardless of where I captured that data or where I run the database, I can very easily connect to it and connect to it through a notebook. Like this example, I'm connecting to the cloud for travel advisories. This one's pretty fun because we're using BM25 just to show you different ways you can connect with sparse inverted indexes. I mean, we support so many different ones. It depends on your use case, which makes sense for you. One thing that's cool in Attu, which I liked, is you saw this search here. What's nice is remember we said different consistencies. Well, if you're not concerned that the data is done, you could put eventually in, like if you're inserting things like crazy, which maybe we can insert a couple more things. Which one are we on? That is local. So let's run the server. Remember we said, what are those different runs? That one's looking at, let me move the camera a little bit. See if that gives it a little different thing. So that'll be here, like while it's running, you could pick strong where you don't want it available till it's fully there, all those sort of things. You could change how you group by things. What do I want to group by? Only current time. And get your results. If I want to export this, I've got a CSV file, which I can now use for whatever I want there. You could filter by whatever you need to. Again, pretty cool. If you want to just look at the raw data, pretty easy just to browse through it. Again, probably don't want to look through the vector. That's a lot of numbers. It's kind of like looking at the matrix. Maybe you see stuff if you look at it enough times, but I don't. For this one, this was the one from the travel advisories, at which we take an RSS feed, process it, and get it in here with a fast index. Again, searching stuff here is very fast and easy. I mean, regardless of where we're running it. What other source code we have? The pose estimation is new. This is one of the examples that come with the Raspberry Pi 5 AI kit. And I just co-opted it for my own purposes. And every couple of rows I insert it, because otherwise I had thousands of rows of my head not moving much, which is not very exciting, especially when I'm sending all those messages to Slack. Again, you put whatever you want in your app, but I like to output to Slack in these distributed event systems, just because very easy for me to know what's going on, good for debugging. Also good to be able to share that information. And this is an open Slack group. So if you want to join, you could join and you could see my weird messages that get auto posted there. And there's some of them connected to AI chat, all those sort of things. If anyone is interested in coming to my meetups coming up or the other meetups, we've got a bunch of them coming up in the next couple of weeks. We got one in San Francisco at GitHub. I'm still trying to figure out where mine's going to be. We'll be in Manhattan. We're trying to find a big enough space because last week we had 260 people register. I know a lot of them were going to be virtual, but we want to make sure everyone has a seat, everyone gets some food, and we've got a bunch of speakers for this one. I'm doing a short talk. We've got an interesting guy who's developed a reporting search tool on top of Milvus, as along with some other databases, which lets you do SQL, which is pretty cool. We got a principal engineer from NVIDIA. Got my friend David coming in from Stream Native doing Gen AI plus streaming. We got Jacob Marks from Voxel 51 coming on, doing some interesting stuff. So it's going to be a packed agenda. So definitely come out to the meetups. Definitely give it a try in the environment. I hope we answered that question before. If we didn't, we'll definitely reach out and put that in the follow-ups. Thank you for coming to the webinar. Hope you had a good time. I think we're probably out of time here.
Yeah. Yeah, so we're at the top of the hour. So thank you so much, everyone, for joining. If you have any follow-up questions, Tim's QR code to his LinkedIn is on the screen. Connect with him on either LinkedIn or X, and he'd be happy to answer your questions. And join our Milvus Discord if you have Milvus-related questions. Okay, thank you all for joining, and we'll see you at the next one. Bye.
Bye. Thanks for coming.